Okay, so guys, I'm back now for with the lots of indices. We are gonna start with, we have like different types. Some I don't even know like their name, but I know like how they work. We have the multiplication sign. Why do I like sign? Multiplication law. I'll start with the general. For every law, I have a general, say, I don't know, general formula, which will help you understand all the other um mm, what complex equations or expressions. We have what to say, a to the power of m. I'm here trying to adjust, times a to the power of n. Oof, this thing is equal to a, because what you do here, you can see a and a must are the same, ne? These are the base, this is a base and this is the index, ne? A is the base and m is the index power, index number, or the power. So what you do in this law, you keep the same base. In this case, the base is equal to a, and then you add the powers, which is m plus n, ne? So it's just gonna be m plus n. Okay, so an example here, I would say maybe x squared times x to the power of 3 is gonna give you, you keep the same base. Sorry guys. Okay, anyways, you keep the same base, and then which the base in this case is must x, ne? And then you add the powers, so it's going to be x to the power of 5, ne? So you can have so many examples. You can have like more than one base, so like you can have 1,000 bases. As long as you understand the law, it won't be hard to like manipulate and stuff. So another one with more than two bases would be maybe x y squared times x squared y. So you keep, this is most the base, ne? The x here, we have the base x and the base y. So first start with x. You can see here this x is not, it looks like it doesn't have a power, but it has a power. The one here, we don't write the one because the one is there by default. It doesn't make any difference, because then x to the power of 1 is still gonna give you x. It's still gonna give you x. So it's gonna be 1 plus 2. So and then we go to the y, the base of y, or the y base, I mean. So we have y, and then we add the power. So it's gonna be 2 plus 2. So this is obviously x to the power of 3, y to the power of 4. Then we go to the next one, which is gonna be 2, the second one, I mean. So it's the division rule. These things are more or less the same. So here we, instead of adding the power, we subtract the power, but we still keep the same base. So we have a to the power of m over a to the power of n. You know, this is almost the same as a to the power of m divided by a to the power of n. It's the same thing. So what you do here, you still keep the same base, and then you subtract the power. It's always the top one minus the bottom one. It's not n minus m. No, it's m minus n. Are we together? Are we together? God. Okay, sorry guys. Anyways, so in another example, we can use x to the power of 3 over x to the power of 2 is an example. I don't want to use, bring the two first, because it's gonna take me to another law which I did not explain yet. So I'm gonna like use that later. So you keep the same base, which is x, and then you subtract the power. Is going to be 3 minus 2. So it's not 2 minus 3, but 3 minus 2. So this is going to be x to the power of 1. But you don't write 1. 1 is like, it's there by default, so it's just going to be x. It doesn't make any change. If you put a 1 here, it's still going to be, yeah, that. And then the one with more than two bases, example, we have x squared squared, y squared over maybe say 3x y. So you look at the bases. The base here is what we have x. Then you have obviously 3 minus 1 because there's a 1 here. And then you have y, 2 minus 1. So x squared, and then you have y to the power of 1, but you don't write 1. You can also have like numbers here, you know, like you can maybe have a 4 here and a 2 here. Obviously you have to divide them. It's gonna be 4 over 2, then you have maybe a 2 there. Yeah. The next one is what we call what is the next? Okay, the negative, not the negative, but the bracket, the raising power. I don't really know the name, but it's a to the power of m, and everything inside is raised to the given power, which is in this case our given power is equal to n. So it's gonna be a m times n. Yeah. So this is a m n. And an example here would be say you have x 3. So everything should be raised to that given power. Ne? So we have it's gonna be x 3 times 2, which is gonna be x to the power of 6. Or you can have another one which is related to this one. So you can have, it can be we have this one, it's we can call it 3b. We can call this one 3a because they are all related. So you have a, b, m, ne, for example. So what you have here, it's gonna be a, everything should be raised to the given power, ne? So it's to the power of m, and then you have b to the power of m. But if you had it like say a, n, b, and then to the power of m, it's going to give us a, n times m, and then b to the power of m. So this is going to give us a, m, n, or nm, however you want to put it. It doesn't change anything. And yeah, an example here would be say 2a to the power of 4 raised to the power of say maybe 2, yeah? Or say 3. An example. So what you do here is you raise everything inside to the given power. So just know that if you somehow get confused, please don't multiply 2 times 3. The 2 should be raised so that this is a power which should be raised here. Yeah? Every number or every whatever number, or not number, but every base, not base, number, or say every variable, I don't know the name, should be raised to the given power. So in this case, we are going to have 2 to the power of 3, and then we have a 4 times 3. We are just taking it from here. So it's going to give us 8a to the power of 12. We are done. So you can, like, maybe if you somehow maybe don't really understand it, you are confused by the power, since there's no power here, just know that there's always a power here, which is gonna give it, which is what, a 1. So what you do here, what you can do here, maybe you can say 1 times 3, but you can also do either, it's easier to do it like here, but there are different ways of killing a cat. What is the next one? The next one is gonna be the negative power rule. The negative power rule. So what happens here in mathematics, we don't leave our answers. I'm going to continue here. We don't leave our answers in negative forms. Ne? So what happens, you have, like, for example, a to the power of negative. And negative forms, I mean the power shouldn't be negative. So you have to do all you can to make it positive. So how do you do that? There are rules. You change the position of that certain whatever is affected, and when the position changes, the sign of the power also changes. So if it was a numerator, it becomes a denominator. If it was a denominator, it becomes a numerator. But no, this is a single like a single variable. I don't really know the terms. Or a single element, not element, a single variable, for example, this one. So but just know here they say what? They say a 1. I talked about this. If you have something like this, a, there's a 1 there, there's a 1 there, there's a 1 there. but this thing does not change anything. That's why we don't put it, so this means now it's going to be 1 over a n. And if we are more than 2, then we have a, say negative n, b. There's a b. So what happens here? I can go out. Oh my god. Sorry guys. Anyways, you can see here, the b is the only one which is affected, but the a to the power of n is not affected. Sorry, the b is not affected because it doesn't have a negative power, but this one, the a to the power of negative n, is obviously affected. So we keep the b because the b is most, these things are most, the numerator as we talk, because there's a 1 under, so it's a b over a to the power of n. It has changed its position from a numerator to a denominator. Another one would be a, maybe negative 2, b 4 over a negative 3, maybe b. So what happens here is this is now a plus, we put now a positive here, so you keep the same base, which is a, and then sorry, not keeping the same base, I just said okay. So what you do here, you can see this is a to the power of 2, b to the power of 4, a to the power of negative 3, and b. You can see that there's only one which is affected here, so which is a to the power of 3. That means all the other ones will keep their position. So we have a squared, you have b to the power of 4 over b. So we have to bring the a up. It's gonna be, so I always find it easier to write it like it's a dot a3 dot b4 over b. So then we go back to the multiplication rule. So it's gonna be a, keep the same base, 2, and then you add the powers, 2 plus 3, b 4 minus 1. You can see here this is most the multiplication law, and this one is the division law. That's why here we have added the power, and then here we have multiplied the power. We have subtracted the power. So it's going to be a to the power of 5, b to the power of 3. And then the next one would be 0 power. So we know this very well in math, that everything raised to the power of 0 is equal to 1. So we know a to the power of 0, this is going to give us 1, We have a to the power of 0b, this is going to give us 1. Nope. You do like, we usually like do this mistakes, The only thing that is affected by the negative, by the 0 is the a. You can see that this is not in the bracket. It's like only the 0. It's only raised here, but not here. The b is not affected. So what you have, so this is gonna give us b. And if you, for example, had x, y, 0, maybe z, gonna give us this. You can see this is in the bracket, so obviously this is, if you go back to what you were doing, it's gonna give you x 0, y 0, z. That means all these two are affected by the 0, so the only thing that is left here is the z. So then the answer is the z. What else? What else? I think that's it for now. I'm gonna continue next time. What other did I maybe forget? Yeah, I think I'm gonna like I think I'm done, guys. So thank you so much. Please don't forget to subscribe to my channel. And I'm so sorry for anything that has happened here. I've had people disturbing me so much. I'm really pissed right now, but it's all right. Next time I'm gonna chase them out of my room. See you guys. Bye.